All right, my name is Anders Heilsberg. I'm a technical fellow at Microsoft. I'm the chief architect for C#, and also have worked as the architect for the LINQ project, which I'm here to talk about today. The LINQ project, which stands for Language Integrated Query, is basically about solving this problem, the impedance mismatch that we have between databases and object-oriented programming languages. Whenever you write applications, I'm sure all of you, I'm not even going to ask, I'm sure all of you access data in your applications, which means when you're writing your apps, you're not just having to learn C# or VB or whatever language you're using to write the app. You're also having to learn SQL, which is a whole different language with a whole different type system, a whole different concepts, and you're having to learn the APIs that bind these worlds together. And while each of the worlds in and of themselves are tremendously powerful, I mean, like .NET with objects and classes, and I mean, like big frameworks and everything, and SQL Server with, you know, the relational algebra and a query processor, and lots of power on each of the two platforms, but the APIs that bind them together and the integration story leaves a whole lot to be desired, right? I mean, when you write queries in C#, if you're writing SQL queries, they actually sit in strings in your program. They get no statement completion, no type checking. You don't discover until runtime whether there are errors in them. Data types are different in between the two domains. And the world is very asymmetric. You can query data as long as it's in the database. But the minute you take it out of the database, you can't query it any longer. So now you've got to like contort yourself and sometimes actually shove the data into the database so you can query it just so you can take it out again, and like all sorts of stupid stuff. With the LINQ project, we're taking some big steps towards fixing this impedance mismatch. Basically, language integrated query extends C# and VB with native support for queries right there in the language as a first-class concept. So you can query data. You can, of course, query data if it sits in a relational database, but you can query data in in-memory arrays and collections with a SQL-like, it's not SQL, but it looks a lot like it, but with the same expressive power as SQL and XQuery, but built right into C# and VB. You can query, as I said, in-memory arrays, collections. You can query through an object relational mapping, talk to relational data, or you can use the LINQ to XML API that we built to query XML data. So it really sort of unifies and brings to a higher level of abstraction the whole notion of data-driven programming. In fact, while the problem that we're solving with LINQ is this sort of very real-world impedance mismatch between the two worlds, we're actually, in a sense, just a manifestation of a trend that generally is true in the programming community, or has been and is more and more true. And it is this move from an imperative programming style towards a more declarative style of programming. And LINQ is just one example of this. There's lots of domain-driven apps and domain-specific languages and the resurgence of scripting languages, and there are all sort of examples of this. And I'll show you sort of in code what I mean by this, but let me just talk about it a little bit sort of at the abstract level. If you look at how we write programs today, or at least how we have been writing them up until today, it's been a lot about, when you're writing a program, it's a lot about saying what you want done, but it is also a lot about saying exactly how you want it done. Like, you know, in a language like C# or Java or C++ or whatever, you have a bunch of imperative statements like for loops and if statements and so forth. And if you want to do some manipulation of data, it often turns into a bunch of instructions about, well, take the data from here, add 2 to it, put it into that array, and then add it to this dictionary, and then data bind this list, and so forth. And you're sort of moving stuff around at a very imperative level. You're saying a lot about the how you want it done more than you're just saying the what. And if we want to sort of make programmers more productive and take advantage of newer kinds of hardware and whatever, it's pretty clear that the imperative style of programming has kind of run its course. It's not like there are whole new kinds of statements like for and if and whatever that we sort of missed, and boy, if we added those, we would be 10 times more productive. Probably not. you know, we're kind of done with that, I predict. However, the declarative realm, actually really, we can speculate about 10x improvement in certain domains like data or like CRM apps or whatever, given the right tool set and the right ways of expressing your intent without expressing exactly how you want it done. And LINQ is an example of that in the data domain. When you're writing queries with LINQ, as you'll see, you're not saying how you want these queries done. You're not saying the exact algorithm you want to use in a join or a group by. You're just saying you want a join or a group by. And if the stuff you're querying is in memory, we can do the join in memory. But hey, if what you're querying are two tables in a relational database, then we can send a query to the database and execute it there. And likewise, as we get, you know, more powerful hardware from dual-core processors and whatever, we could discover, hey, there are 4 cores sitting on this machine, and you're asking me to do some big sort here. Why don't I run it in parallel on the 4 cores and collect the results quicker? And because you're not specifying the exact way you want it done, it gives us a lot more freedom to be smart in the execution infrastructure about how we do these operations. And really, so my point here is LINQ is an example of this move towards a more declarative style. So the LINQ project starts with the abstract notion of language integrated query and a bunch of new, well, I wouldn't say a bunch, there are actually not all that many, but some new APIs in the system, like support for expression trees and standard query operators that are all part now of the .NET framework. On top of this, we then have extensions in C# 3.0 and VB 9.0. These are all part of the Orcus release of the Visual Studio toolset coming later this year. And in C# 3.0, VB 9.0, query is now a first-class native concept, just like if statements and for loops. It is that native. You know, you can apply it to anything. Now, out of these pieces, we then build a series of APIs that allow you to query different kinds of data. And the core API there is an API called LINQ2Objects, which again will allow you to query anything that implements the IEnumerable interface. And every collection in .NET implements it. So right out of the gate, you get a complete SQL XQuery-like query language that you can apply to any kind of data structure that you have in your program. Now for the relational realm of data, we have several new APIs. Well, we have extensions to some APIs, and we have some new APIs. LINQ, we now have support for LINQ over data sets. LINQ2SQL is a new lightweight OR mapper that we're shipping in Orcus. And LINQ2Entities is a heavier, more enterprisey, that gives you more richer mapping capabilities that we're shipping about 6 months after Orcus. And then finally, LINQ2XML is an XML or query-enabled XML object model. And all of these share a common programming model for accessing, transforming, querying data. I should also say that there's a rich extensibility model that allows third parties to build LINQ providers, and we're seeing a lot of those already from third-party OR mappers and interesting projects like LINQ2SharePoint and LINQ2LDAP, like Active Directory, LINQ2Amazon. Someone built a little thing that puts a queryable interface on top of Amazon's web services. So lots of fun stuff there. Okay, so that's a brief introduction to sort of the concepts behind LINQ. And what I'm going to spend the rest of my talk, or most of my talk on, is just one big demo to show you all of the sort of capabilities in these various APIs. In this talk, I'm going to specifically focus on LINQ2Objects, LINQ2SQL, LINQ2XML APIs. So let me switch here to, this is a build of Visual Studio Orcus. This is a little later than Beta 1, so I could show you some of the newer features, but right now there's Beta 1 is available for download on the web, and this is sort of an early Beta 2 that I've got going here, but it's pretty much the same stuff. And I'm going to sort of start out by just showing you a traditional imperative application, an ASP.NET app written using sort of standard C# 2.0 style. And then I'm going to show you how I can transform it into a more declarative style, and then from there take it into some of the other features in LINQ. So what I have here is just an ASPX page, a real simple one. I just have a data grid on the page. That's all I have on it. And then in the code behind the page, I have declared a class called product, because I'm going to operate on some product objects here. This is all in memory. I'm not accessing databases yet. I will later. And you can see for my product, I just have some instance variables and constructor, and then some properties, you know, where I'm stuffing data into my instance variables. So product category, product name, and unit price. And then in my code behind the page, I have a method called getProducts that'll just new up a bunch of products and add them to a list. And then down here, I just get my products. And then let's say now I want to do a little query on this stuff. I want to like show in my data grid all the products whose unit price is greater than $20. Now that's relatively simple to do with traditional coding. I could for each over all of my products, and if the unit price is greater than 20, add it to the result list and then bind to the result list. So that's what I'm doing here. So let's try and run that, and we'll see. And here we see the result of that. Okay, so now let's say I wanted to do something a little more fancy in here. For example, let's say I wanted to group up all of the categories of these products and count how many products are in each category, just on some in-memory objects, right? Well, that gets a little more complicated. I could write 2 nested for loops and some counters or whatever, or if I was really smart, I could write some code like the stuff I got here, where, whoops, I think I grabbed the wrong code, sorry. Well, actually first, if I had to group stuff, I would need to first write a little class called grouping, you know, that I can put here. And in my grouping class, I would have to collect up category IDs and counts of products, okay? And now I got to compute the groupings then out of my list of products. And to do that, I would have to grab some code like the following, where I create a dictionary of int comma grouping, and then I loop over all of the products, and if the dictionary doesn't contain this product, then add a new grouping, otherwise increment the count, et cetera, et cetera. As you can see, it's very hard to tell what I'm really doing just by looking at this code. You know, if I hadn't written the code, I wouldn't know that this is doing a grouping over something, because it's all about the how and not about the what. But nonetheless, if I save it and go refresh the page here, you'll see that I get, you know, the categories and their counts. Now let's say I, for example, then wanted to sort it by product count descending. Well, then I'd have to get even more painful here. Grab some sorting code. Don't try this at home. Create a list of groupings, and then call result.sort and passing a delegate, you know, that can compare by product count and so forth. And sure, it works if I do it, but you know, this would have probably taken a while to write. And indeed, when you look at the code, you go, I have no idea what this code does, and it would take me a while to figure out that I'm doing a grouping and then ordering it by product count descending. Now let me show you how we can move with C# 3.0. We move towards a more declarative style, and with LINQ, you know, the combination of C# 3.0 of EB9.0 and LINQ makes this a lot simpler to deal with. So I'm going to transform my code here. First, I'm actually going to abbreviate this product class down to just this. So this is actually the same class, but it uses a new feature in C# 3.0 called automatic properties that allows you to declare a property, and then we automatically make the instance variable behind the property. So here you see I just declare product, thank you. Product category, product name, and unit price, and we automatically make the instance variables behind that. I'm going to get rid of the grouping because it turns out I'm not even going to need it. Now for my get products list, or my get products method here, I'm going to paste a C# 3.0 version that uses another one of C# new features called object initializers. So this is get products, returns a list of product, and then you'll note in here that I just say return new list of product, followed by an open curly, and then I specify the contents of the list right here. And the content of the list is new product, open curly, and then I specify the property values of each of the products. So it's very declarative, really. It's almost like markup, if you will, right? Where I'm just declaring my data here, in a sense. There are no products.add, you know, this is one statement that just returns the data in a declarative fashion. Now, let's try and transform the actual code here. In fact, let's get rid of all this gobbledygook. And then, first thing I'm going to do is I'm going to use a new feature called local variable type info. I'm just going to say var products equal get products. I'll come back and explain what that does. And then I'm going to write my query now, var query equals from p in products. And you see here I'm writing a query now, and I actually get statement completion on things that are available for me to query. So from p in products, where p dot unit price greater than equal to 20. Select p. So that's my query, and then I'll just bind to the query. So let's save this and go back, refresh. And here you see all of my products with a unit price greater than 20. And really, all I wrote were two statements, get the products and query over them. If I wanted to group them, I could go from p in products, group p by p.category ID into groups called G, and then from each group select category ID equals the key for the group, which is what I was grouping by, and count equals the count of how many elements are in the group. Now I'll get back and explain exactly how this all works here, but just observe. I save, I go back here, I refresh, and now I have all of the products counted up by each of their groups. And if I wanted to order them, I could say order by the count descending. Save that, go back, refresh, and you see that now they're ordered by count descending. And if you go back, certainly you stand a much better chance of understanding what this app does by looking at this code, because it states the what, but not the exact how. Now it turns out that, yes, we implement this by having because I'm querying in-memory data, we will create an in-memory dictionary and blah, 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 blah to do the grouping, and we'll do a quick sort to do the sort, and so forth, but you don't actually have to worry about that. Okay, so let me talk a little bit about the features you just saw here. First of all, I used local variable type inference. You'll see that if I hover over this var here, so var basically just means take the type that occurs on the right-hand side of the equal sign and use that as the type of my variable here. You already know what the type of this expression get products is. It's a list of product. So when I say var, that just means give me a variable of that type. And indeed, if I hover over the var, you'll see that, oh, the type is system collections generic list of T, and T is product currently. So this is just the same as saying list of product, but it's shorter hand. In a sense, it looks very much like JavaScript here, but it's actually all strongly typed. So you get the terse syntax without the price of losing the type information. The type information is still there. It's just not explicitly said all the time. Now, the next thing here is this query syntax that I'm writing. And let me explain a little bit about how this actually works. So when I write a query, like, well, let's try to go back to our simple little query we had before. From P in products, where p.unit price greater than equal to 20, say, select p.product name, for example. So real simple. Let's just save that. Let's run it and see what it gives us. And it just gives us all of the product names of our products. Now, the way this actually gets compiled by the compiler is that this from, where, group by, order by, select, and so forth gets translated into method calls. So this is exactly the same as writing query equals products dot, products dot where, because there was a where clause here. The compiler translates it into a method call on a method called where, and then it specifies a lambda expression, unit price greater than or equal to 20. And then because there was a select clause, we put p arrow p dot product name. So these two things here are identical. The compiler, whenever you write a query, just translates it into calls to methods called where, select, order by, group by. Now those methods then can either be implemented by the thing you are querying. In this case, my list of product could implement its own where, order, group by, select, or so forth. Or they can be extension methods, and that's actually what's occurring right here. Because, you know, last you checked, I'm sure you've noticed that list did not have a method called where or select. But if you look at the top of my file here, what I'm doing is I'm importing system.link. And in system.link, we define a whole bunch of extension methods for anything that implements IEnumerable of t. In fact, we implement a complete query language as methods. If I press F12 here, which is navigate to definition, you'll see that we end up in a class called system.link.enumerable that declares a whole bunch of methods in here, like where, well, let's look at briefly. There's max, min, there's a where method that I'm on right down here. There's select methods, et cetera, and it actually constitutes a complete query API that we can invoke either as regular methods or use the more gentle query syntax that I was using. If you go back and we could look at which is the select method, if we navigate there, you'll see that this is actually the method called select here, and that is an extension method that extends IEnumerable of t. So anyway, I'm sort of getting down in the nitty-gritties of it here, and it doesn't really matter all that much, except that my point here is that this is a very extensible system, and you can hook in at a bunch of different levels, and that's what allows other third-party OR mappers and so forth to hook in and evaluate these queries by themselves instead of relying on our in-memory query evaluation. Okay. Now, the one other thing I wanted to show, again, was the strong typing. One of the things that you typically do when you write queries is you do projections, where you do filtering, projection, ordering, and grouping. Those are sort of like the meat and potatoes of queries, right? And you've seen me here do filtering. I briefly did a projection. I'll talk a little bit about that again. Let's say from my products here, I want to, for each product, project out the product name and the unit price. Now, in an object-oriented programming language, there isn't really the notion of projection. Like in SQL, when you write select x, y, z from some table, what SQL does is, on the fly, it creates a new type, if you will, that has 3 columns, the ones you projected out, and then it gives you a sequence of rows of that type, so to speak, right? Now, in an object-oriented programming language, the way you would create a projection is you would take data from one type of object and put it into another type of object. And that would sort of be your projection. You could take customers and project into a contact type that just has name and phone number, for example. But of course that gets to be tedious because you have to go declare a grouping class or a contact class like you saw me do before. But in C# 3.0 we support the notion of anonymous types. So you can declare types on the fly using this syntax new open curly. And that's what I'm going to do here. So I'm going to say, as a result of my query for products, I simply want to select out product name and unit price. And what the compiler does when I do this is it creates a new type that has 2 properties, product name and unit price, and then it projects data into new instances of that type, and it returns a sequence of those, and that's the result of my query. Indeed, if I hover here, you'll see that the type is IEnumerable of t, and t is an anonymous type that has product name and unit price. So the IDE actually knows what's going on here dynamically. Now if I run it, well, let me first save, try to refresh the page. You'll see that, yep, I got my projection. Now, but here's the kicker. If I were to now, say, write a for each loop over my query, for each var x in query, and I say x dot you actually see statement completion here. So we know what you projected out in your query, and we make it available to you in statement completion because it's all strongly typed. And this is one of those things that in a dynamic language, you could write something that looks like this, but when it comes to getting a statement completion or whatever, you know, the type information is gone, and you don't get it. So anyway, well, thank you. All right, now, okay, so real apps, of course, don't new up list of products in memory. They get it from somewhere. And I'm gonna first show you how to access XML and then how to access relational data. Let's say here, for example, I wanted to get my data from an XML file instead of getting it from this in-memory list here. So I'm going to get rid of this getProducts method. There. I'm going to go up and import system.xml.link, which is the new LINQ-enabled XML object model. And then I'm going to use it to read an XML file. In fact, let me open that file. I have products.xml here sitting in my data directory. And you'll see here that it's just, you know, a root products and then a bunch of repeating product elements that have ID, name, supplier category, blah, 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 blah. And in fact, it's the same data that I just had in memory. But this time I'm going to read it from my XML file. So let me paste in a getProducts method here that reads it. Now, in order to read this, I first say xelement.load of my products.xml file that I just showed you. And then I dot into the elements sequence on the element that I just loaded, or the element sub-collection, if you will. And I ask for all sub-elements named product. And then I write a query over those where I say from each element E in those, select out a new product, and then I use an object initializer here to just fish out pieces of my XML, and I cast them to int or string or decimal and assign it to my product. And I have now effectively, this is a transformation of XML directly into a list of objects. This is all the code I have to write. And then I just, at the bottom here, use the toList operator on my query that says materialize this query and make it into a list of whatever it is. And this gives me my list of product. Now, let me save this, and I can refresh here, and well, lo and behold, well, actually you do see a little change because there were more decimals in the XML file on my prices, and so you see something changed. But this data now actually came from the XML file. And you see how LINQ isn't just about querying, it's also about transforming data. Here I used a query to transform from XML into objects in a very sort of intuitive fashion. At least intuitive once you work with it a little while. Now so one of the other pieces of data I have is a categories.xml. And lo and behold, it has, you know, category IDs, category name, descriptions, and so forth. Let's say for each of my products, well, I could right now easily display category ID, right? If I save that and refresh, and you see category IDs. But let's say I wanted to show category names here. Well, now I need all of a sudden to do a join of two pieces of XML. Now, and I could, of course, code that up myself, and a couple of days later I might have something, you know, but it's non-trivial, right? Because you've got to make a dictionary and da-da-da-da-da. But let me show you how we can just first declare a category class the way that we declared a product class. Pretty simple again, you know, it's just one line per property. And then we could write a little piece of XML, again, that looks just like the getProducts XML, that reads the categories. It's exactly the same. Just iterate over them and pump out category objects for each of the elements. And now I can go write myself a join of these two things simply by first saying var categories equals get categories. And then from P in product, join C in categories. Oops. Join C in categories on P.category ID. equals C.category ID. And now I have them joined up, and now I can simply down here, instead of referring to P.category ID, I can refer to C.category name. Pretty intuitive. I mean, this is what you would do in SQL. Thank you, thank you. Well, let's see if it works before you applaud, shall we? Sure enough, it works. Thank you. And of course, you know, I could continue on here. Well, let's order by C.category name. Save that. Refresh. And now they all come out nicely sorted. And you see, it's like query is ephemeral all of a sudden in C#. It's a native part of the language. And the expressions you write, you'll note, these are C# expressions that can call methods of your own, methods that you authored yourself. You know, there are no restrictions on it here. It really truly is a part of the language. Okay, now of course, let's see here. Okay, so now we've covered in-memory data, we've covered XML data, and of course I've left out for the end here the big one, which is relational data, which is where most of the data comes from. So why don't we start looking at that? In fact, I'm going to take this same piece of code, I'm just going to leave it here, and now I'm going to change it to get the data from relational. And I'm going to show you how this same query with no changes still keeps working. In fact, I have declared here, I'm going to use this new API or new feature we have called LINQ to SQL, which is a lightweight object relational mapper that allows you to map your classes onto SQL Server family products like SQL Server, SQL Express, SQL Server Compact Edition. And you can do it in a variety of ways. I'm going to start by just putting attributes on my classes. So notice how I simply add some attributes to my product and category classes that talk about how they map to data in the database. Well, I should maybe first show you that on this machine I actually have, you know, a Northwind table. And if we go in here, there's our Northwind database, and in here there's products. And if we show the table data, you'll see that we have the same data available in SQL Server. And now I'm going to map my classes onto this relational data in the database. And I do that by putting these attributes on where I say, hey, this product guy, he maps onto the products table. And this property product ID, it's a column, and it also is the primary key, by the way. And these guys are just columns with the same name. Now I could specify the name here in the mapping. I could do a bunch of different things, you know, but sort of out of the gate, if I just say column, that means it's a column with the corresponding name. I do the same for categories. Then I can get rid of these guys because I'm not going to read XML anymore. There. And now let me go grab a little piece of code here and substitute just this instead. So what I'm going to new up now is an instance of an object called data context. And data context you can think of as a connection to your database, but it's a strongly typed connection that can convert results of queries into objects, if you will. And I say connect to SQL Express, the Northwind database. And then I say, hey, products is get me the product table, and categories is get me the category table. And this now maps them onto these classes that I wrote. We get the metadata out of attributes. And then this query here, I don't change it at all. And let's try and just save. Whoops, did I save? Yep, and then let's try to refresh here. Whoops. And, I forgot to say using system.data.link. Gotta import it. And since I'm writing the mapping right here, I also gotta import system.data.link.mapping. Let's try and save that. And now you'll see these guys actually bind. And there we go. And now the data actually came out of the database. Now, of course, how can I prove that to you? So let's try and add some logging and actually look at the traffic that goes on between the database and my app. So I'm going to paste in a little piece of code here, a little region of code. In this region, so first I should explain, one of the capabilities we have on data context is you can assign to its log property a text writer. And then it will spew all the SQL out on that as it submits it to the server, and then you can examine what's been going on. So I just create myself, I declare myself a text writer here, and then in the preload of the page, I just say appended to log.sql, which so happens to be a file in my solution here. And then on page unload, I just write a line there and close off the log. Okay, so with that, I can now say db.log equals my log here, save, press F5 over here, see we get the same result. But now if we open up log to SQL, we can now look at what got submitted to the database. And here you see, select product name, category, unit price, with products, join category where blah, 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 blah. Basically, the query I wrote translated into SQL. And we're going to look at this log some more and look at some of the queries that go across, but this sort of gives you a brief idea of how it works. Let me maybe briefly just show you a couple of slides on what LINQ to SQL allows you to do. Here are some of the concepts that you deal with in the database on a day-to-day basis, like databases, tables, views, columns, relationships, stored procedures, actually also table-valued functions, but they didn't fit on the slide. And LINQ to SQL allows you to map them onto CLR concepts. So we can map a database onto a data context. We can map tables onto a class and a collection that represents the table. The same for views. We can map columns onto properties in classes. We can map relationships onto nested collections inside objects. So for example, a customer can have an orders collection. Well, we can map a foreign key, primary key relationship between these two into a nested collection. And stored procedures we can map onto methods on your data context. And the same for table-valued functions. So you can call them directly on your connection, if you will, as normal CLR methods. And I'll show you all of this stuff. But briefly, just sort of the way LINQ to SQL operates is if you have your app and LINQ to SQL and SQL Server, when in your app you write a query, well, actually, when you write a query, nothing happens, interestingly, because queries, all execution in LINQ is deferred. So writing a query and storing it in a variable doesn't actually execute it. The query doesn't execute until you for each on it or try to obtain the result of the query. That's when the query executes. And this gives us great compositionality, and I'll talk about that a little bit later, because you can combine queries without them having expensive temporary results and so forth. But anyway, when you try to enumerate this query, then the app goes to LINQ to SQL, asks for an enumerator. LINQ to SQL then takes the query, translates it into a SQL query, and then the results of the SQL query come back as rows out of a data reader, and then we run those through an identity map inside LINQ to SQL and attach them to a change tracker that can track the objects, and then we give them back as objects out of your enumerable. And now the app can then obtain a bunch of data, and then it might actually start modifying the data. It might, for example, add a customer to the customers table and change the city of one customer and remove another one. And once the app is done with its changes, it can call submit changes on the context. At which point LINQ to SQL, but aided by the change tracker that it implements, will submit the appropriate either dynamic SQL or stored procedure calls to effectuate those changes in the database. So that, in a nutshell, is sort of how the workflow happens here. And it's important to notice that you can use stored procedures as sources of data, and you can use stored procedures to do your insert, update, deletes, or you can just have LINQ to SQL generate dynamic queries and whatever. But you know, we fully embrace both ways of working with data. We're not going to get into the religious battle of whether one is better than the other, because they're both good. Okay, so that's sort of briefly what this stuff does. So let's try to go back to our app now and do a little more experimentation. In fact, you saw me manually add attributes to my classes here, but really that's typically not how you would want to work. Rather, you'd really just want to point at the database and have these classes be generated, right? And we do, of course, support that way of working as well. through a visual designer. So I'm going to go to my project here, and I'm going to say add new item. And we're going to add a LINQ to SQL file, and we're going to call it Northwind because we're going to work with the Northwind database. Northwind. Okay, yep, put it in the app code folder. And up now comes a design surface where I can drag tables and stored procedures and table valued functions and so forth. And we're going to start just by going to Server Explorer here, and then let's grab the categories and the products tables and drag them onto the design surface. And this gives me now a nice little data diagram over these classes that I'm in the process of importing. Now I can select them here and then start modifying properties on various things, and indeed because of a few little inconsistencies here, I need to go modify a couple of things where we get the defaults wrong right now. For example, here I'm going to say update check always. This has to do with how we handle optimistic concurrency. Let me reset this guy too. Then I'm going to take my product ID and make sure that it is not read-only. The same for my category ID. Basically what I'm doing here is I'm changing properties of my properties, if you will. So I can change here whether I want them to be public, whether I want them to be read-only. Right now we have an inference rule that doesn't work so well. We're going to get rid of it again, but we were inferring that product ID and category ID to be read-only because they're auto-generated in the database, but that gives us issues when in some cases. So we're gonna not do that. And then unit price here, I'm actually just gonna change that to not be of a nullable type. Anyway, save this, yes, and if I go look here, you'll note that we now actually generated a file out of the DBML. We have generated a CS file that really is just the class declarations that I was writing before, but this time they're auto-generated. You see a category class with some instance variable and then some property accessors. There's some property notification goo in here, you know, just so that you can data bind to them and whatever. So they are a little bit bigger than the ones I had written. But you basically also see how well, we generate product and categories, and then the one thing we also generate is a class that represents the entire database called Northwind Data Context here. And think of this as a strongly typed connection to my database. Just as we're giving you strong typing on the tables by having classes that map the tables, this is a strongly typed mapping of the database where each of the tables are properties in the connection. So I can just say connection.categories, connection.products, and now I'm talking about those tables. So in fact, let's go back and modify our code to use this. So we're going to change this line here to say var db equals new Northwind data context. And then we can get rid of this stuff as well. And then in our query, we can now just say from p in db dot products, and you see we get statement completion on the database, if you will, here. I can just select the products table and then join C in db.categories. And that's it, really. So let's try and run. And ideally, we get, yeah, well, nothing changed. But if we go to our log, well, actually, you'll see our log got modified. Yes, let's reload it. And if we look, you see the same query got executed this time, you know, through the auto-generated mapping. It differs a little bit on some of the table names. Yeah, we put DBO here instead or whatever, but you know, it's the same thing. Okay, now one of the things you'll note in, or you may have noticed in the visual designer, is that there's this arrow between category and product. This is a relationship between, it's a one-to-many relationship between category and product that we can infer by looking at a foreign key, primary key that existed in the database. And basically, we map that automatically onto a nested collection in category and a property and product. So category will have a products nested collection of all of the products in that category that represents that join. And likewise, product will have a category property that is its category, you know, the one it refers to by that foreign key, if you will. And I can simply now, instead of having my join be written explicitly here, I can rewrite my query to just deal with, since what I wanted here was category name, I can get rid of the join line and then simply go in and say p.category name. Because, and this property just refers to that join, if you will, or that relationship. So if I save, refresh, order by p.category category name, of course. Let's refresh again. And we see the same result. If we go back, yes, we'll reload the log and look. And you see, again, the same query executed. Actually, it changed a little bit because this became a left outer join this time, because I was doing an inner join before, but now it's a left outer because it could possibly be null. But you see again here how it is certainly a lot gentler to just talk about the relationships as objects graphs that you can navigate as opposed to explicit joins, but also note that we do allow you to do both. It's not like you must do it one way or the other way. Okay, stored procedures are obviously very important in any kind of database programming today. And I'm going to show you how you can import stored procedures. So if we go into the Server Explorer here and we look at stored procedures, while that expands, I'll hydrate a little. Boy. And in here we see we have sales by category is a stored procedure, and I can import that simply by grabbing it and, oops, well, I can't drop it here. Sorry, gotta go to the designer first. Let's do that. Go back here. Sales by category and drag it over in the stored procedure table value function pane here, and that imports that stored procedure. And now if I save here and I go look at the generated code, yes, you'll see that in my connection, my Northwind data context, I still have my categories and my products table, but now I also have a sales by category method that returns an IEnumerable of sales by category result. And if I follow this one, you'll see that we've actually declared a class representing the result of the stored procedure. And now I can simply go ahead and start coding against that. So let's get rid of our query here and say from s in db.sales by category, and you'll note that I get statement completion now on my stored procedure here. It says it takes 2 string parameters, so beverages, comma, and for some reason it takes the year as a string. I didn't write that stored procedure, so I'm just going to go with it. In fact, let me just make my query be that to begin with. And save it, and let's go back and let's refresh here. And here you see the result of my stored procedure call. And indeed, if we go back and we look at the log, you'll see that we did an exec return value equals blah, blah, blah. So this actually called the stored procedure, delivered the result. Now, the cool thing about this, though, is that the stored procedure here returns an IEnumerable of something, and IEnumerables of something can be queried. So I can say from S in the result of my stored procedure, order by S dot, and again I get statement completion here, order by total purchase descending, for example, and just select from that S. And let's save that, and let's refresh. And you see now, result is ordered descending. Now, one thing you might wonder is, well, how did you do that? Because stored procedures, you know, I mean, they're executed and just deliver their result, right? Well, because the stored procedure was declared to return something of type IEnumerable, this query actually happens in memory. So you'll see that the call is the same, and we sort it locally instead. Now Now you're going to go, well, that's bad. Well, you know, because I wanted it done in the, well, but so if you had written this instead as a table valued function, and I so happen to have one of those, so let me go to my DBML file here, Server Explorer, and then look at table valued functions or just functions, and one of them is table valued, and it's called products under this unit price. In fact, we could just look at the code in it. It just returns select star from product where unit price less than blah, which is passed. So think of this is really a parameterized view, right? And I can import that. Products under this unit price, just grab it over. Let me go back. Let's save that. Go back here. And let's try and call that guy. Oh, actually, the one thing I want to do too. Since products under this unit price actually returns products. Now, if you look at what happened in our code generator here, if we look at what got generated, you'll note that we generated a products under this unit price method that returns iQueryable of a products under this unit price result type. Now, that so happens to be a product. Now, but we can't tell that because it's nowhere set in the schema anywhere, you know. But what you can do as you're mapping these, you can actually in the designer say, hey, the element type of this should not be auto-generated. It should be products. And at that point, we will map it onto your products. So you can actually use table-valued functions as your queries for your entities, if you will, that then go into the change tracker, get tracked and whatever, and then you can do updates through sprocs later and whatever. So let's go back here and take a look at it. So now I can say from p in db.products under this unit price, there it is, say 20. And let's actually just say order by p.unitprice, and from that say select new p.product name, comma p.unitprice, and save that, and let's try and run it. Whoops, did I not? Oh, yeah, okay, so the unit price is nullable here. This is a bug in our data grid. Sorry, let's try and do it this way. Go back here. And there you see the values. Now, if I go back and look at what got executed in my log here, you'll see that it actually incorporated this into the query. Select product name unit price from products under this unit price parameter, and it passed in the parameter value 20. So there's like deep integration here between, you know, table value functions, tables, views. They're all sort of viewed the same way by the mapper. Now, I could indeed even here say p.category. P.category. Well, maybe I didn't map. Anyway, okay. Let me keep going here. Actually, there's so much other stuff I want to show you. Indeed, I want to get to insert updates and deletes. Now, so far I've just read stuff from my database, right? But obviously you're going to want to modify things. Now, if I go back to my mapper here, you'll note that one of the sprocs I have is an insert category sproc. And let's say that whenever I create new categories, I actually want to use that stored procedure to create the category. So I can go ahead and import that. And then I can go to my category table and say, for inserts, instead of using runtime, and what use runtime means is generate dynamic SQL, what I really want to do is I want to use a stored procedure here. So I'm going to customize and say, use the insert category method. And then we go look at the parameter names of insert category, and we look at the parameter names of your object, and we just sort of match them up automatically. Now, if they don't match, you can do the manual by hand mapping, but we just go with, you know, name-to-name mapping, and this so happens to work in this case here. So what I've said now is the category table, whenever I create new categories, I want to call a stored procedure. For products, I haven't said anything, so when I create new products, that just becomes an insert statement. Now let's try and go back and actually write some code here to do some modifications. So we're going to keep this, we're going to get rid of this. And the first thing I'm going to grab is a piece of code that does an insert. Indeed, what I'm doing here is, again, I'm using an object initializer to just new up some objects. So I'm going to say category, or var cat equals new category, and here comes the property values. Category name equals lawnmowers, products equals, and products is the nested collection that I had in my category, equals open curly, and then I'm going to put new product, and then da 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 da. So really, I'm in a sense just declaring some stuff here. I'm declaring a category with 2 products in it. And then I just go to the categories collection and add it. And then I say submit changes. And that's all I need to do here. So let's try and save it. And then, of course, what I should have then, I should have kept my query. But let's say var query equals from p in db.products. Select new, and then let's just select p.product name, comma, p.category name, comma, p.unit price, just so we can verify that we actually get it. There. And let's actually just say order by p.product name, like so. Okay, so let's try and run this. Actually, why don't we first clear out the log file here, just so we can observe afterwards what ended up happening. And then let's refresh here. And so at this point, my inserts executed, obviously, because you see the resulting query I got. I have my Master Turbo and my Weed Wizard here in my lawnmowers category with the unit prices that I specify. Now, if we go look at the SQL that got submitted, you'll see that first, oops, actually, I guess I didn't get my insert executed here for some reason. I'll have to go look at that. Okay. Let's see. Let's go back to the oh, I forgot to save it, the designer. That's another bug here. Sorry about that. Let's save this guy. And of course, well, now, of course, if I run it, okay. Anyway, now if I run it, the products will already be there. So you're going to have to trust me that it would have done an insert. Sorry about that, but there's just you know, the usual demo stuff here. Anyway, so here I would have gotten a call to the Sprock to insert the category. And then you see we fetch out the, here now from the insert, we fetch out the auto-generated category ID. Then we do an insert into products and fetch out each of those guys' IDs. And then finally we do the select at the bottom there, which was, you know, the grid that we filled in. So this is pretty efficient stuff that gets generated here. If you look at it, it's tight SQL. It doesn't select more than it needs to, and so forth. Now, let me try and do a bit of updating also. So let's get rid of this stuff here, and let's grab some code that does updating. Paste that here. In this particular case here, we do another query where we say, give me all the lawnmowers, and then multiply their unit prices, so raise the lawnmowers by 10%, and you know, basically, and submit the changes back. Let's clear out our log, save it. Let's go back here, and then let's refresh and see what we get. Well, you see the prices on lawnmowers went up, and if we look at the SQL that got generated, you'll see that we start now by querying for the guys, and then we update, set unit price equals blah, where, and here you see how we generate optimistic concurrency checks that check that none of the other column value change, you know, because if you were in the middle of a transaction and so forth, we update the other product, and then we select back the result. So again, pretty tight stuff. And let me finally show what we do to delete. There. And here we just say, well, give me the lawnmower category, and then just go remove all of its products and remove the category itself. Again, also pretty simple stuff. Let's try and clear the log and save it. Save this. Let's refresh. And the lawnmowers are gone. And if we come back here and look at the log, you'll see that we have first select the first select the category and then select the products out of the category and then delete, where product ID, delete the category itself and select back the final result. And again, each of these, dynamically generated SQLs, if you had mapped onto stored procedures, we would have called insert, update, and deletes on those instead. Another thing that's important in data apps is paging. Let me try and get myself back to my var query equals db, equals from p in db.products. Let's see, order by p.product name. Select new, and then let's just get the data that we had before, p.product name, comma, p.category name. Oops, sorry. Comma, p.unit price. Okay, so this was the query that we were dealing with before. Let's say that you were building a web UI here where you wanted to do paging on this stuff. Show me page 1, 2, 3, and you want 10 per page, for example. Well, I could just change my first query here, call that query 1, and then write another query equals query 1 dot, and then I can use two operators in LINQ to SQL, or in LINQ, called take and skip, that allows me to skip a number of elements and take a number of elements out of my sequence. I could, for example, just start with take and just say, hey, this query here is query 1, but take the first 10. So this is like top 10. Indeed, if we save and refresh, you'll see that I only see 10 now. And if we go back and look at our SQL that got generated, you'll see that it's a select top 10, blah, 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 blah. Now, there's also a nice one called skip that allows me to skip a number. And I could, for example, say skip 20 and take 10. And that's how, if you're on page 3 or 2, depending on whether you start with 0 or 1, you would just write it like that, right? If I save that, refresh here, you'll see that I see some other guys. And if we go back and look at the query that got generated for this, you'll see that this actually, well, it dynamically detected that we're on SQL Server 2005 that now supports the new row number capability. So you see the query gets rewritten to select top 10 from, and then select row number over yagadi and whatever mumbo it is you have to do to check that a row number is greater than 20, which is what happens here. But you see how we can do all of those transformations that are mind-boggling, complicated to normally do just over data. And the cool thing, of course, is that these same operators work if you had an in-memory array. So if you were like paging through an in-memory array, you still nothing changes in the query. Okay, so final thing I want to show is a new control that we have in ASP.NET called the LINQ data source. So I'm going to get rid of this stuff here. Actually, the whole thing, just commented out. Let me go back to my, close off some files here. And let's go back to our web page, and then from the toolbox, let's go grab the LINQ data source. And I'm sure some of you, I'm sure you've all worked either with the SQL data source or the object data source before, and this is really sort of the LINQ equivalent, that you can just point at a data context and then it gives you automatic paging, insert, update, deletes, dynamically generated where, select, order bys, and so forth. I'm going to show you that briefly here. So we're going to start by configuring our data source. It automatically detects that Northwind data context is the only one in my project, so it just goes with that. And in here we can pick the products table, for example, and say finish on that. And then let's say we will enable insert, updates, and deletes on this data source. Okay, final thing I want to do is I want to just go to the event handler here, and on context created, I want to create an event handler where I just put a snippet of code to attach our log again, just so we can see the SQL that goes across the wire one more time. Okay, then what I want to do is go to my grid and choose a data source now. and I'm going to go with my LINQ data source. And then you see the grid then fills itself in with all of the columns from that table. And now I can go ahead and start, for example, enabling paging, sorting, editing, and deleting, say. Okay, and let's try and run this. Oh, actually, I didn't want to. Well, it doesn't matter. I'm running on the debugger now, but it doesn't matter. And here you see stuff that was automatically generated for us, basically. And now paging is available. I can go page 2, 3, 4. And if we stop here and go back and look at our log, you'll note that this generated a bunch of, well, first select count, because the grid is like figuring out, well, how many are there? And then select top 10, blah, 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 and you saw those. So basically the grid underneath the covers here is just doing a count operator, and then it's doing a take and a skip operator on the data source that we've set up. This thing also allows us to do paging and sorting. So I can sort by product name or sort by product name descending just by clicking on those columns. And if we go back and, again, look at the result here, you'll see down here that now we have order by product name descending or order by product name and so forth. So again, this is simply because the LINQ data source is dynamically attaching an order by on the query or on the source of data. Okay, last little thing I wanted to show you with this guy is some dynamic querying. Let me go grab here from the toolbox. Whoops, sits down at the end here now. Oh, actually, I wanted to just go put a dynamic where clause on this guy. So here I could put a where clause. I could actually open a little editor for dynamic filtering. And here I could write an expression. Let's say I want to see all products with a unit price greater than or equal to some minimum price. So I say unit price greater than equal at min price. And then I add myself a parameter called min price. There. And this is a query string parameter, and now I get to say what is the query string field called, and we'll call that min price also. And we'll default it to 0, and we'll just give it the data type decimal right here. Okay, and let's try and run now. And now, if we go up here and we then say min price equals 20, you'll see now when I sort by unit price that, yep, they're all minimum price 20 and so forth. So you can directly wire up query string parameters that go into dynamically generated where clauses. These things actually get parsed out by a little parser that generates expression trees. And so you could actually still go against in-memory data with all of the same infrastructure, or you can go against relational. Okay. So that was a very mega demo. Let me get back to the slideware here and just wrap it up. So the LINQ components you saw me demonstrate here are, well, first of all, the concept of language integrated query, which effectively is like native query in C# and VB. You saw me demonstrate LINQ to objects that gives you SQL-like query capabilities on objects in memory. LINQ to SQL, which is our lightweight OR mapper. LINQ to XML. And some of the sort of new things here about LINQ is well, obviously, as you hopefully can tell, this really truly unifies query transformation and operations over object relational and XML sets of data and gives you this SQL and XQuery-like power directly in your favorite programming language, lots of tool supports and so forth. And I think that's it, and I think I'm out of time. I'll take maybe a couple of questions if you haven't, but otherwise, thank you very much. Thanks. Yeah? Well, there are two OR mappers, LINQ to SQL, which is what I demonstrated here, and then LINQ to entities, which is part of the ADO.NET entity framework that we are shipping in first half of 08. And the entity framework gives you richer map. It actually gives you conceptual modeling where you can start with a model instead of starting with the database, where you just model your data and then map it onto a database. The two technologies, we're working on aligning them more, you know, but effectively think of this one as the one you work directly with your data, and it gives you really strongly typed data access. Yeah.
You showed in the select statement that you could use the parent name to achieve the child value.
Right.
Does that work back for write for update? Can you use that to update the child, and so therefore use the containment relationship in an object to just update an object and have it figure out which tables to update?
Yes, yes. So, yeah, so you can, I mean, if you have like a category, you can navigate into its products collection and start modifying in there, or you can modify which category object you wanted a product to be in, and that automatically generates an update statement and so forth.
The topmost class to update itself in
Yeah,
the tree gets
yeah, exactly.
So you essentially have enterprise data objects implemented within ADO.
You should think of it as LINQ to SQL really is a push button data access layer. You know, you point it at the database and poof, it pumps out your data access layer. I didn't even have a chance to show you some of the customization capabilities, but you can actually write code in the property setters and getters to add your validation logic. You can write partial classes for each of the generated classes where you put your business logic and so forth. So yeah, it saves you a lot of work. Yeah.
Do you have a tool that will write those classes for all your tables?
Yes. So I showed you the visual designer. I neglected to say we have a command line tool that you can just point at a database and it pumps out a mapping for the whole database. Yep. Yeah.
When you did the explicit join, I noticed you used keyword equal.
Yes.
Boolean.
Right.
There's a story there.
There is a story there. The only kind of join we support is an equi-join. So if we had you put an equals, that would have probably made you think you could put a greater than equals and do the other kinds of joins that no one does. but so therefore we picked the keyword equals. It's also sort of to indicate that it is not the same as the equals operator that's going on right there. It is really that I'm equating this with this in the join. Do you know what I'm saying? Yeah. Right.
If you selected all your customers and were loading all their orders underneath it, that can...
Sure. So yeah. Absolutely. There's lazy loading. There's also the capability of attaching, we call them data shapes, and they are really, think of them as when you create your context, you can then specify context-wide filters for all relationships. So you can say for all orders of a customer, I only want them if years greater than or equal to blah, and filter that out. You can specify whether you want lazy loading or eager fetch of relationships. You can even shut off lazy loading if you want to make sure that nothing gets fetched, you know, at any point. So there's lots of fine-tuning control that I just simply didn't have time to show here. Yeah.
Why do you not follow the order you use SQL, like you select and follow the bottom and then set it on?
Yeah, good question. One of my favorite questions. Why isn't the select clause at the beginning? Think of how you would implement statement completion for a system like that. So every query starts with select. So you're typing now, select space. What are we going to show you? We have no idea where data is coming from. Do you know what I mean? There's something funny about the ordering in SQL that you're specifying what you want before you've specified where you're getting it from. In a sense, I think that the more natural ordering is you specify where you want it to come from, then you specify the operations, and then the projection at the end. Indeed, that's how it actually executes inside the server. I actually speculate that a lot of the confusion about writing nested queries in SQL is precisely because SQL made the mistake of putting select first. Because scope of variables that you declare in your from clause actually goes backwards into the select clause, but not into nested queries. Do you know what I mean? And your head explodes. So where if you put the select clause at the end, scope starts where you say the variable and it flows until the end of the query. And it's a lot more intuitive. And we're not the only ones to discover this. If you look at xQuery, which is a more modern query language, does the same thing. You start with the fors, it's the flower expressions, right? You start with the for let where returns, and the return is your select. So it's just, I think we all learned from the mistake, if you will, of putting select first. I'll take 2 more, and then I gotta get out of here, I think. Excellent statement. Excellent question, I mean. It would be nice if it, yeah. We allow you to map XML value in the database onto X elements, which is linked to XML elements. We currently do not allow you to query into, at least not, we actually, in memory, you can query an object graph that has XML in it and query into it. We cannot remote it to the database currently. This is an excellent feature to think about for a V2, where we would translate the link to XML part of the query into an X query and send it to the server. And certainly all the infrastructure is there to allow it to happen. Yeah. Let me take the last question, I think, right there. Yeah. We do support those. In that case, I forget what the name of it is, multi-result set or whatever. But that allows you to then walk up to that and say, give me results at a blah, and then you get each of them. What's that? Type safe, yes. Yes. All right, thanks everybody.